Okay, so thank you everyone. Thanks for being here in this session. We will speak time series anomaly detection with Azure and .NET, and this is part one. And this is part one because we will have a second session on September 23rd, and we will go deeper. But I told you next at the end of the session. So I am parenzan. As I said, I come from Italy, from Pordenone. I'm a solution architect. I have a community here in Pordenone where we speak about these kind of topics. I am an Azure MVP, and these are my profile if you want to contact me after this session. So Simon told, read in my abstract that I'm not a data scientist. Yes, this is true because I am more a .NET developer. I am an IoT developer because this is what I do on a daily basis. I like to say that I am a one-man band. Obviously, I am a company. I am in a company, and I have a lot of colleagues and with a lot of skills. But sometimes you find alone. On working on some topics. So, yes, I have also a background of an individual professional. So my mind comes from one-man band, where you have to handle some topics that you are not very comfortable. For example, data science. Data science is obviously a current topic for these days, and we have to work with. So my comfort zone is mainly .NET. So all my research is about how can I handle these topics with .NET if we can, obviously. So let's introduce a scenario where I have this situation. And the typical scenario where I have this need is an IoT scenario. Thinks about IoT, thinks about temperatures. Yes, if you make some work with Arduino, with Raspberry Pi, and you work with some sensor, you play always with temperature. But temperature is a real measure that you need, that you work with on the field. For example, if you speak about real industrial fridges in which you monitor temperature. About temperature, because you have a condenser where you have to exchange heat, and you have to monitor if the temperature go away from the fridge in the correct way. So again, it's not just a play. Temperature is a correct measure in the IoT field. So in the IoT field, we have a device, we have a fridge, we have the temperature sensor, and we collect probably with IoT Hub and with some sort of IoT ingestion, we collect the data into a storage for following processing. What do you mean? What do you do with processing IoT data? Well, first and foremost, there is the batch processing. That means you collect and then you process data in the following time. You don't do always real-time processing. Why? Because you don't think that you have real-time need to discover some kind of strange things or outliers that can come in your data. Yes, you have always streaming, but we can start from batch. What you can do with that batch data, you can calculate efficiency if you are consuming correctly energy, if your distribution of energy consumption, for example. And this is typically a BI, a business intelligence topic, in which you present a report with your graph and you see the trend. But what about anomalies? Anomalies is something that goes outside the trend. Something that has to be distinguished from the normal trend. yes, visually you can understand that there is an anomaly, but how can an algorithm recognize automatically that there is some outlier in the topic? And so this is all about anomaly detection. Anomaly detection in time series. That means events that are sequenced in time. So events that are ordered in time and have to be considered as event ordered, because without ordering you cannot consider this. Anomaly detection of a time series make assumption that there is probably the outlier. So the anomaly is something that is very rare. So you can distinguish because it's a value that comes outside from the normal trends, and that is very distant, very far from the normal trends. And this is how anomaly detection in time series works. Why we have to use data science? Because the threshold anomalies, that means a level, using a level upper or under that level distinguish, like for example this second graph. It's not every time this way, because if you look at the first graph that you look here, you see that the thresholds are continuously different, but is that we can say the percentage, we can say the ratio between the normal and the outlier that becomes the anomaly. But this is not just one value over. This value changes every time. And this is why we have to use other algorithms rather than something about threshold. So our topic is how do we implement the process of working with that data to understand the outliers. Again, as I told you, I'm not a BI analyst, I'm not a data analyst, I'm a .NET developer, and we can say we are alone. Thinks that this kind of project is inside an IoT enablement project where there is no specific focus on that data. In general, there is no specific finance to find analysis. You spend all the money to implement the ingestion architecture, and then you say, okay, next you have to implement some logic on that data. And in your team, there is no resources about that. So I'm a data developer, and I have to understand if the anomaly are present. And so all my journey has become, how can I become a data scientist with my comfort zone? So let's discover which are the pillars of a typical data science, a modern data scientist. First, Spark. Spark is an engine, is an open source engine, is a cluster management platform that allows to implement batch processing, real-time processing that scales, because it can work on few data, it can work with big data, so gigabyte, terabytes of data in a scaling and elastic way. So when you work with Spark, you find a couple of scenarios: batch processing and notebooks processing. Batch processing means you create a script, you create a program that you run on Spark. You load the data, the Spark works with the data, and then you obtain your data. As there are notebooks. Notebooks are a tool, an interactive tool, where you can write code. You can write code on the Spark cluster, and then you obtain intermediate data, and you can change your code as you are writing. So you are experimenting, sketching code until you find what you wanted to do, what you wanted to find. So these are two important tools. Overall, notebooks experience is very common. Very common. In fact, you have the Jupyter tool, that is the notebook implementation in this web-oriented, data science-oriented world. And then there is obviously Python. There is also Python. Why Python? Because it's simple to start. It is open source. It has a lot of data science tools on that, and so in university and companies, it's quite simple for that to adopt Python. Remember one thing about Python. That yes, when you speak about TensorFlows, PyTorch, you think it's Python. No, there is a library behind that is a native library. So the algorithm is not implemented immediately in Python, but is native code, C code, and then you call it from Python. The same way is Spark. Spark is written in Java. So there is a bridge between Python and Spark. So that Python can speak with Spark through Java. And the same is Jupyter. Jupyter is a web application, is not written in Python, it is written in Java. And this means that also here there is another bridge that is called kernel that allows Python to speak with Jupyter. So this is the scope. This is the background where typical data scientists work. So let's discover which are the tools that we as .NET developer have in our toolbox and we can use. First, in the data science scenario, you have two specific main differentiation: supervised and unsupervised machine learning. So unsupervised machine learning means no labeling, because me as a developer, not a data scientist, not an engineer, I don't spend time to label the data to understand which is true, which is false, to train my algorithm. I want something automatic. And that's why there are some algorithms. One of these is spectral residual CNN, convolutional neural network, that are implemented, and this specifically was implemented by Microsoft itself, that it works like an automatic training tool. So you as a developer, you don't need to train the algorithm. It trains itself with the data you give to the tool. And this is good because we want to spend the time to work, not specifically to train and then just to work. And this is good for us as developers. So let's speak about specifically the .NET toolbox and what .NET gives for you as a data scientist. First and foremost, ML.NET. ML.NET is a library like PyTorch, like TensorFlow, with which you can run data science algorithms, machine learning algorithms natively on .NET. You install in your application and NuGet packages, and then you can implement this. In fact, for example, in this are all the tools, all the interfaces, all the tools that .NET implements. You see, okay, sorry, the arrow is moved. You see that here we have anomaly detection. So in ML.NET is not only a platform to implement ML algorithm, but you have directly an algorithm, that's algorithm SRCNN already implemented. And then you can already use it in your application. So ML.NET is a good library to implement anomaly detection. And then you have .NET Interactive. .NET Interactive is the support from the .NET framework, from .NET as a scripting to support Jupyter and Visual Studio Code to implement the notebook experience. And so if you install .NET Interactive, you can have a C# kernel inside Jupyter, or you can use notebooks in Visual Studio Code, writing in C#, and also you can write in F# or in PowerShell, for example, PowerShell core. And this is really, really great. And then you have .NET for Apache Spark. That is binding, the same binding that Python has to write code that runs on Spark. And so you write in .NET Core, and this is great. You don't have to learn Python to write code for Spark. And that code can be run not only on your own cluster on your machine, but you can also run on Synapse, for example, or for example, on Databricks. And this is very great. And then there is the Azure Toolbox. What Azure gives us to support time series anomaly detection. Time series anomaly detection, the algorithm that we've seen, for example, the ML.NET code that you can write, can be implemented and hosted in Azure Function. Azure Function is a good way to implement anomaly detection that receive the last sample, the time series to process and to understand which are the outliers of that. Then there are completing services in which you have different areas, because you have custom vision, you have speech, but also you have a decision area where there is the anomaly detector. The anomaly detector is an out-of-the-box service, is a SaaS service in which you call a REST API, you send the data, and you obtain the output. You don't have to teach anything. You don't have to configure anything. You have just to configure. You prepare a REST request and then obtain the response. Then you have Azure Synapse. Azure Synapse, as included inside it has Spark, so you can host your Spark cluster under Synapse, and then you can also write Python .NET notebooks inside Synapse. And this is very great. And then you have Azure Data Explorer. Azure Data Explorer is specifically a platform to manage time series. And you have a custom language that is custom, in which you have specific language features that allow you to understand if there are outliers in that time series. So you can have a specific service like Data Explorer, or if you want, because you are a business intelligence-based skill, you can also use, again, Synapse. Okay, as we will have a more deeper session on next week on the 23rd, let's look at two fast demos for this session. The first one is this one. This is .NET Code, .NET Core code inside Visual Studio, in which you have what? I have a package that you see, it is Azure AI Anomaly Detector. Okay, so you write a console application, or then, as I told you, you can wrap this code inside an Azure function, for example, and you just add these few lines of code. You create a service instance of anomaly detector inside your Azure subscription. You obtain an endpoint and a key. You have your CSV file, which you read as a CSV file. You instantiate your client to the service, and then you can have your processing. Let's look at entire detect sample. So you create a request in which you put your points, and then you just have a request, and that's it. One request, one invocation, and then you have your result. This is just a demo code. You can, with this library, you can detect all the outliers of the series, or you can detect the last outlier in the series, because you can think, I have a batch for all the day, give me all the time. I have packages for 15 minutes, half an hour, and you send each half hour. And so you need the last one, and you send incrementally all your invocation. And this is the threshold. Or you can have also the change point, understand where there is a change in your line trend, so you can understand there is a change. Just to look at how it works. Okay, here it is, prepared by request. I have the points. I have all the points. Just invoke, and then you have your result. Okay, just demo. Okay, and you have all your sample data. Okay, and then you probably want to represent. I don't have it in this demo, but I will have in the next week. For that, the other demo is this is Visual Studio Code, and you see that I have an IPy notebook. That is a Python notebook, a Jupyter notebook inside Visual Studio Code. And you see that the kernel that is represented is .NET Interactive. What it means that this is C# code, and we can execute some code. Okay, this is how notebook works. You have markdown code that is just text, and you have a line of codes, and you can have a complex line of code about that. Okay, you have tools to represent all of this. Just to show how it works, I clear the output. You see that you can add, for example, a NuGet package. Okay, you see that it is installing, it's downloaded from NuGet, a package for Plotly. That is a library that is born in HTML and JavaScript that represent graphs. Okay, download the NuGet using create a random generator, create a functional time series, and then you have chart plot. And this is how data scientist works. It works with notebooks to understand, to explore your data, things that the code that you have look with the anomaly detector to put inside this notebook. You will see in the next session. But okay, you understand that you can run everything you want that is HTML based inside your notebook, and you write in C#. And this is very great. This allows me that I have no Python knowledge, I have no time to spend to learn a new language. I use my C# code, I use my C# skill to write this kind of code. And that's it. This is what I wanted to do. So understand the message is that the .NET ecosystem in data science world is completing. So it is not behind, is far from. No. .NET is ready to work 360 degrees to cover all the topics. Things that C# is Pythonizing, C# 7 to work to have all the simple syntax that Python users love. Things that you can host your .NET code on the Spark. Think that you experiment your .NET code inside .NET Interactive. And think that you can host all this code in Azure because you have many services that can run this code to make you data science. So that's it. That was my objective, to create an overview about the .NET, to tell you that .NET is a language that is ready for the data scientists. I invite you the next week on September 23rd to look at part 2, sorry, not part 1, to look at more complete demo in which you will see ML.NET, Azure Functional Hosting, ML.NET, and Azure Cognitive Services, and all that code hosted under Synapse and in Azure Explorer. Thank you.